We're going to look at properties that are built in a rectangle, starting the same way as we did with the parallelogram. We are going to start with a triangle and then rotate it about a midpoint. And when it's done, it creates a quadrilateral. I think you'll recognize this quadrilateral. This happens to have formed a rectangular shape. We see many of the properties that we saw before. Opposite sides are equal. Yes, we see that. We see that opposite angles are equal. We see that happening here, and it's the same here and here. But actually, in this shape, all of the angles are 90, aren't they? You say, well, why would these be 90? Notice in our diagram that the dot and the solid dot together must be 90 because 90 and these two make 180. We also see one of the properties about diagonals, a new property about diagonals, is that not only do they get bisected, but they are actually equal. So all four pieces of the diagonals are not only bisected, but equal in that design. So some new things there. We also see the other experience where the consecutive angles sum to 180. So all of those parallelogram properties here, and then the new ones have to do with the four equal angles, four right angles, and then as well diagonals that are congruent, kind of new. Let's look at another example. If we started with this right scalene and we rotated it, it would create similarly one of what we would expect, which is that rectangle again. Looking closely at the properties that are formed, we see four right angles, but that's what we could expect because in that rotation. Why do these have to be 90? Because we know that an X here and the dot here make 90, so this has to be 90. We see the opposite sides that are equal to each other. And then we see this diagonal business. The diagonal here gets split, but also here and here. A very important idea here, my friends, very important. And I want you to notice this. Let me pull out something to color with. This creates isosceles triangles. This is an isosceles triangle. So you're going to need to know those base angles are equal. And this is also an isosceles triangle. And then there's an equal pair on the other side. Those isosceles triangles are going to give you base angles that are equal to each other. So be very, very aware of that. That's going to help you out with solving problems. So let's identify what we know about this guy, the rectangle. It is a type of parallelogram. So yes, the opposite sides are parallel and the opposite sides are congruent. Adjacent sides are perpendicular, right? That's what it means, right? Four right angles. That is true that the adjacent sides are perpendicular. It does not have four equal sides though, so that's a no. Opposite angles are equal. Consecutive add up to 180. They do, don't they? This guy right here and this guy add to 180 and so on. That's true. Are four angles equal? That is also true. Do the diagonals bisect each other? Yes, they do. They cut each other in half, but the diagonals are also perpendicular. And so this, and this are equal. Again, I'm going to warn you, it's very important to know that the base angles of these isosceles triangles have to be equal. That'll help you out. Quick recap. Yes, 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 no. Yes, 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 no, no. Let's use these properties now. Let's do it. This is 76. And so this is 76 in this corner. Those would be alternate interior angles, right? Remember what I just was warning you about? This line is parallel to this line. And so there's your transversal. Now, base angles of an isosceles are equal because we learned in a rectangle, the diagonals are all equal. So I just picked up the other angle. And then this adds up to 152. So that must mean that z is what's left of our guy, which would be 28. So I could not have done that had I not realized that this and this were base angles of an isosceles. New problem, but I see the trick already. And so hopefully so do you. These have to be the same, don't they? Because they're base angles of the isosceles triangle. Here's the isosceles, or one of them. So I know z is 38. Now, I also know that every corner here has to be a right angle. So that's got to be 52. X has got to be 52. Now, let's get into y. Now, I know that this is also 52 because the base angles of that isosceles have to be equal. That's 52 and 52 make 104, which then leaves 76 as the y value right there. What I notice about this is that these are about lengths of diagonals now, not about angles. And I know that those two have to be equal to each other. I know that all four pieces actually have to be equal. So I would say 4x plus 14 must equal 2x plus 40. And that gives me 2x equals 26, and I would get 13. Now they want us to find AC. AC starts here and does half of a diagonal and then the other half, and so it's one full diagonal. Now remember, in this shape, the diagonals are equal. So we need to plug that 13 back in to obtain its size. And when we do that, 4 times 13 plus 14 is 66. And so this would also be 66, and so would this. So our answer to that length would be 66 and another 66 for 132 centimeters. So we found x first and then had to plug it in to find one of the distances. Let's do one last one. This is always kind of a classic one to be done. We know this is 10, yes. We know this one is 24. But they want us to talk about diagonal pieces like AE or BD. And to do this, you need to see something appear, which is a right triangle. This happens to be, of course, a rectangle, so this is a right triangle. And now I can use the Pythagorean theorem, which would say 10 squared plus 24 squared equals, in our case, dB squared. And that would give us a total answer of 26 from one end to the other. Let's see, though. So that would be our answer to, our answer to x is just 24. Opposite sides are equal. Our answer to AE or BD, well, BD I have written down is 26. And AE is just half of the diagonal. And remember, all of the diagonal halves are equal, and so that would just be 13 in each of those cases. The key here is the Pythagorean theorem. I will say that shows up here in particular because you have a right triangle. And anytime you pull out a right triangle, this guy right here, he's going to show up. So if you're stuck, remember this experience, right triangle, Pythagorean theorem.